morning everyone. My name is Abhinav Yudi and today I'm presenting a video on cloud computing. So these are all the topics that we are covering in this presentation. What is cloud computing, why cloud computing, cloud characteristics, architecture, technologies, deployment models, service models, advantages and disadvantages. So first of all, what is cloud computing? It is a technology that uses the internet and central remote servers to maintain data and application. Cloud computing, to put it simply, means internet computing. The internet is commonly visualized as clouds, hence the term is cloud computing or computation done through the internet. The cloud computing users can access data resources via the internet from anywhere for as long as they need without worrying about any maintenance or management of actual resources. Cloud computing allows consumers and businesses to use applications without installing and access their personal files at any computer with internet access. This technology allows for much more efficient computing by centralized storage, memory, processing, and bandwidth. Then why cloud computing? Cloud computing builds the infrastructure to support cloud computing for more than a third of all IT spending worldwide, according to the research from ITC. Meanwhile, spending on traditions in-house IT continues to slide as computing workloads continue to move to the cloud, whether that is public cloud or any other clouds like private clouds or hybrid clouds. And this is a graph that is showing cloud computing as a service revenue. Then following are the cloud characteristics. So first of all, it's self-healing. So what do you mean by self-healing? Is that an application or any service running in a cloud computing environment has the property of self-healing. In case of failure of the application, there is always a hot backup of the application ready to take over without disruption. There are multiple copies of the same application. That means each copy updating itself regularly so that at the time of failure, there is at least one copy of the application which can be taken over without even the slightest change in its running state. And we have multi-tenancy. With cloud computing, any application supports multi-tenancy, that is multiple tenants at the same the same instance of time. The system allows several customers to share the infrastructure allotted to them without any of them being aware of the sharing. This is done by virtualization of the servers on the available machine pool and then allotting the servers to multiple users. This is done in such a way that the privacy of the users or the security of the data is not compromised. Then we have linearly scalable. Cloud computing services are linearly scalable. The system can break down the workloads into pieces and service it across the infrastructure. Then we have service oriented. So cloud computing systems are all very well service oriented. That is, systems are such that they are created out of other discrete services, many such discrete services which are independent of each other and combined to form the service. Another characteristics of cloud is SLA driven. Usually businesses have agreements on the amount of services. Scalability and availability issues cause clients to break these agreements. But cloud computing services are SLA driven such that when the system experiences peak of load, it will automatically adjust itself to comply with the service level agreements. The services will create additional instances of the application on more servers so that the load can be easily managed. Then next characteristic is virtualized. The applications in cloud computing are fully decoupled from the underlying hardware. The cloud computing environment is a fully virtualized environment. At last, we have flexibility. This is another feature of cloud computing service. They are they can be used to serve a large variety of workload type, varying from small loads of a small consumer application to very heavy loads of a commercial application. Then we have the cloud architecture. As you can see, it is consisting of front end and back end. On the front end, we have client infrastructure, and on the back end, we have management and security of applications, services, runtime cloud, we have storage, and we have the infrastructure. And as we all know, cloud can only be accessed via internet. So components of cloud computing architecture are client infrastructure, application, service. It also offers following three types of services: software as a service, for example, Google Apps, Cisco WebEx. Another one is platform as a service. It is also called as cloud platform service, like Windows Azure. And then we have infrastructure as a service, like Amazon Web Services, like EC2. Then another example is Google Compute Engine. So now we have the cloud technologies. These mainly include virtualization, SOA, grid computing, and utility computing. So in virtualization, it's a process of creating a virtual environment to run multiple applications and operating systems on the same server. The virtual environment can be anything, such as a single instance or a combination of many operation systems, storage devices, network application servers, and many other environments. The concept of virtualization in cloud increases the use of virtual machine. A virtual machine is a software computer or software program that not only works as a physical computer but can also function as a physical machine and perform tasks such as running application or programs as per the user's demand. Then we have SOA, abbreviated for Service Oriented Architecture, which allows organizations to access on-demand cloud-based computing solutions according to the change in their business needs. Then we have grid computing, which is also known as distributed computing. It is a processor architect that combines various computing resources from multiple locations to achieve a common goal. In this, the grid is connected by parallel nodes to form a computer cluster. And at last, we have utility computing. It is the most trending IT service model, and it provides on-demand computing resources and infrastructure based on the pay-per-use method. Then we have the cloud deployment models, which include public, private, hybrid, and community cloud. First of all, let's talk about public cloud. As the name suggests, this type of cloud deployment model supports all users who want to make use of the computing resource, such as hardware, which can include OS, CPU, memory, or storage, or it can also make use of software on a subscription basis, like application server or database. Most common users of public clouds, are for application development and testing. Then we have private cloud. As the name suggests, private cloud is typically infrastructure used by a single organization. Such infrastructure may be managed by the organization itself to support various user groups, or it could be managed by a service provider that take care of it either on site or off site. Then we have the hybrid cloud. It is actually the combination of private and public cloud. In a hybrid cloud, an organization make use of interconnected private and public clouds. Many organizations make use of this model when they need to scale up their IT infrastructure rapidly. For example, if an online retailer needs more computing resources to run its web application during the holiday season, it may attain these resources via public clouds. Then we have community cloud at last. So this deployment model supports multiple organizations sharing computing resources that are part of community. Examples include university cooperating in certain areas of research or police department within a country or a state. Then we have cloud service models. These basically include SaaS, which stands for software as a service, PaaS stands for platform as a service, and at last we have IaaS, infrastructure as a service. Let's talk about infrastructure as a service. In cloud computing, it can be broken down into three models, and the first one is infrastructure as a service, which refers to fundamental building blocks of computing that can be rented physically or virtual servers, storage, and networking. This is attractive to companies that want to build applications from the very ground up and want to control nearly all the elements themselves. Then comes platform as a service. This is the next layer up, as well as the underlying storage, networking, and virtual servers. This will also include the tools and software that developers need to build applications on top of. That could include middleware, database, management, operation systems, and development tools. Then at last we have software as a service. Software as a service is the delivery of application as a service, probably the version of cloud computing that most people are used to on a day-to-day basis. According to researchers, IDC, SaaS is and will remain the dominant cloud computing model in the medium term. Then we have advantages and disadvantages of cloud. So the advantages of cloud computing are backup, stored data, plus one. Once the data is stored in the cloud, it is easier to get back and restore that data using the cloud. Then we have improved collaboration. In cloud applications, it improves collaboration by allowing groups of people to quickly and easily share information in the cloud via shared storage. Another advantage is excellent accessibility. Cloud allows us to quickly and easily access store information anywhere, anytime in the whole world by using just an internet connection. An internet cloud infrastructure increases organization, productivity, and efficiency by ensuring that our data is always accessible. Also, it has low maintenance costs, which reduces both hardware and software maintenance costs for the organization. Another advantage is mobility. Cloud computing allows us to easily access all cloud data via mobile also. Then we have iServices in the pay-per-use model. It offers application programming interfaces or APIs to the users for accessing services on the cloud and pay the charges as per the usage of services. Then it also supports unlimited storage capacity. It offers a huge amount of storing capacity for storing our important data such as documents, images, audios, videos, etc. within a place. At last, we have data security. Data security is one of the biggest advantage of cloud computing. It offers advanced features related to security and ensures that the data is securely stored and handled. Then we have its disadvantages of cloud computing. First is internet connectivity. As you know, in cloud computing, every data, it may be image, audio, video, etc., is stored in the cloud, and we can access these data through the cloud by using the internet connection only. If you do not have a good internet connection, you cannot access these data. However, we have no any other way to access data from the cloud. Another disadvantage of cloud computing is vendor lock-in. So vendor lock-in is the biggest disadvantage of cloud computing. Organizations may face this problem when transferring their services from one vendor to another, as different vendors provide different platforms that can cause difficulty moving from one cloud to another. It also has limited control. As we all know, cloud infrastructure is completely owned, managed, and monitored by the service provider. So the cloud users have less control over the function and execution of services within a cloud infrastructure. At last, we have security. Though it provides good security, but it also has issues. Although cloud service providers implement the best security, but before adopting cloud technology, you should be aware that you will be sending all your organization's sensitive information to a third party, that is a cloud. While sending the data on the cloud, there may be a chance that your organization's information is hacked by the hackers. This was all from my side. Thank you all.